Hi everybody, welcome back. Okay, so we're just going to do a few more exponent examples in this video. Please look at the last video if you have no idea about negative exponents or rational exponents. Been dealing mostly with negative exponents. We're going to do some more of that right now, okay? So as I've explained before, negative exponents are hard to deal with. Now, when I'm working with exponents, one of the things I like to do is to kind of think about whether the final answer will be negative or positive. Because my base is negative, it's a question I want to ask myself. Now, because the exponent is an even number, doesn't matter that it's negative, because it's an even number, my answer will end up positive, okay? It has nothing to do with the fact that there are two negatives here which will cancel each other out to make a positive. It doesn't work that way. These two negatives have nothing to do with each other, okay? So if you see this and you think, oh, that'll be positive 8 because the negatives cancel out, no, that is absolutely wrong, and it's a mistake that is made right up into grade 12 math. The way we solve this, I'll come back to this in a minute, the way we solve this is we go 1 over negative 2 to the power of positive 3, okay? And now we take the negative 2 and raise it to the 3, which will be negative, and we end up with an answer of negative 1 over 8. So convention has us writing negatives in the numerator when they happen, okay? So when you have a negative fraction, it's typically, you do not typically write the negative in the denominator, you always write it in the numerator. Because if we write out these three numbers, they all mean exactly the same thing, okay? So, or this for that matter, they all are exactly the same number, but we just don't like to write it this way. Okay, you have to be careful if you're writing, if you decide to write the negative in front of the fraction line, that's great. If you decide to write it in front of the numerator number, that's great. But remember, if you have something like this, then don't write it like this, because these are not the same, okay? Instead, if you want to write the negative in the numerator, you need to bracket the numerator, like so, okay? So please don't make the mistake of thinking that because you see two negatives that they cancel each other out. They've got nothing to do with each other, okay? And I'll be coming back to this concept in other videos, so stay tuned. Okay, so for this one, what are we going to do? Well, we're going to reciprocate this base, which is all of this, and then we're going to have a positive 4 exponent. So we absolutely must keep the brackets there. Okay, if we don't, we're going to end up with the wrong answer. All right, so that's step 1. Step 2 is to say, well, what is, okay, my step 2, my next step for sure would be to say to myself, well, am I going to end up with a positive or a negative answer? Because my negative base is being raised by an even exponent, the negatives will cancel out. So I'm going to have negative 3 times negative 3 times negative 3 times negative 3. And those even number of negatives are going to cancel each other out for a positive final answer. So I don't even have to worry about that anymore. I know that the answer is going to be positive, and so I'm just going to put a fraction line and work the rest of it out. So negative 3 to the power of 4 is positive 81. Okay? X cubed to the power of 4 is x to the power of 12. And the negative 2 to the power of 4 is negative 8. Now, if you can anticipate that that's coming, you can just pop it into the numerator. Okay? It's not really skipping steps. If you struggle at all with losing your way, don't do this. But it's okay here. It's not too complicated. It's a single number, a single thing that we have to move. So it's not too bad to do it that way. This one here, none of the brackets are being raised by an exponent. So we can actually do any cross-canceling or simplifying of the elements that are inside these brackets without regard to the exponents, okay? So I think what I want to do is I want to first of all notice that my final answer will be positive, because this -2, that -12 are not being raised by anything, okay? They're just being raised by 1. So negative times a negative is positive. There's no exponents to worry about. So that gives me 24, and divided by 6 gives me 4. So I'm just going to put a 4 right there, okay? Then I'm going to look at the exponents in my numerator and the exponents in my denominator. I'm going to leave those for now because I don't want to do too much at once because it invites error, okay? So I'm going to first of all do something with these two x's which are being multiplied, which means I'm going to add those exponents. So that's going to give me an exponent of -7 on those x's. The y's are going to end up with an exponent of -1. Okay, because 1 plus -2 is 1 minus 2, which is -1. And then in my denominator, I haven't done anything with that except to get rid of the 6 with the 2 and the 12. So I'm just going to rewrite the exponents on the variables, okay? Now the next thing is to simplify all this variable business, all right? So the 4 isn't going to change because there's nothing left to do with the 4. And then my x's. Okay, so the larger of my two exponents on the x is in the denominator, so that's where my x is going to land. And like I've explained in previous videos, always subtract from the larger number. But subtracting negatives is tricky, so be careful. So what we're doing here is we're doing 1 minus -7, right? Which is 1 plus 7, which is 8. So that's the exponent that we end up with on that x. And then the larger exponent on y is on top. So let's put the y there. And then we have -1 minus -3, which is -1 plus 3, which is the same as 3 minus 1, which is 2. And boom, you're done, okay? So it looked really big and scary, but look what it simplified down to, okay? There's not much left. This one here, okay, first thing I'm going to say to myself is, oh, look at that, I see negative signs. So I want to ask myself whether my final answer is positive or negative. Get that out of the way right away. Because we are dividing two negatives, we're going to end up with a positive final answer. So that's great. I don't have to worry about that anymore. That's taken care of. Now, 54 divided by 6, how's your times table, right? You've got to know your times table, or math will always be a struggle. So if you're in a curriculum where they're not teaching memorization of the times table, memorize it anyway, okay? You should know all the way up to 12 times 12, and even beyond that, especially knowing your squares is really, really useful. So 54 divided by 6 is 9. Okay, now the a's, we're going to look at the a's and we're going to say, okay, the higher exponent on a is on top and the lower one is on the bottom. So we're going to put the a on top because that's where the higher exponent is. And here's what we're doing. We're doing 5 minus -2, right? 5 minus -2, which you have to say this in your head or you're going to get it wrong, is 5 plus 2, which is 7. Okay? The larger exponent on b is in the denominator, so that's where my b is going to go. And here's what I'm doing. I'm doing -3 minus -7, which is -3 plus 7, which is the same as 7 minus 3. Write it out the opposite way if that helps, which is equal to 4. Okay? So if you do this method of subtracting from the larger number, in the case of the a, subtracting from the 5, in the case of the b, subtracting from the -3, you will never end up with a negative exponent here. It'll never happen, okay? And since it's negative exponents we want to try to eliminate, this is a really good method for getting rid of them very efficiently, okay? Okay, so here's a little bit of a twist. What we're going to do is we're going to evaluate these, given that a is equal to -2 and b is equal to 1. Now, of course, you're going to simplify these first. It goes without saying, because to plug these numbers in here and to try to do that math without simplifying first would just be crazy. So we're going to start by simplifying each of them, and then we'll plug in the numbers and we'll see how it works, okay? So so this is all being multiplied. Doesn't matter how it's written out, it's all being multiplied. So a to the power of 3 times a to the power of 2 is a to the power of 5. And the b's have the same exponents, so that's b to the power of 5 as well. Now when we're substituting numbers for variables, no matter whether we're raising them to exponents, subtracting, adding, multiplying, whatever, we're going to use brackets for those numbers, okay? So the a is -2, and that's to the power of 5. The b is 1 to the power of 5, okay? So really the b is absolutely irrelevant here. You could skip working with that b throughout this entire thing, because no matter what power of b we end up with, it's always going to be 1 to some power, which is always just 1. But we will simplify anyway and put the number in just so you can see how the algebra works. But this is not going to have any effect on our final answer at all. Whatever b ends up to, whatever power of b ends up to, it won't matter. So -2 to the power of 5, how's your powers of 2? Okay, remember that this stuff is good to know, is -32. A negative base to an odd exponent is negative. Okay, so here we end up with, so we have a to the power of -1 times a to the power of -2, which is a to the power of -3. And again, the b we could ignore, but for the purposes of learning how to simplify, we're going to deal with them. That's b to the -5. And that's going to end up looking like that, right? Now let's put in our numbers. So we have -2 to the power of 3, 1 to the power of 5. And remember what I said a few minutes ago, we're going to end up with a negative final answer, okay? So always think about that. When you're just about to write the final answer or you see negatives popping up, make sure that you think about whether the final answer will be positive or negative. That's one less thing to think about, one less thing to get wrong. Remember too that when we do have a negative final answer, we want the negative written in the numerator, not the denominator. So this -2 cubed is -8. So we're going to go -1 over 8 because there's nothing else. The 1 to the 5 is just 1, and that 1 in the numerator just stays 1, but we want to pop that negative sign into the numerator. It's just better, okay? Here we're going to get, so the larger exponent of a is on the bottom, so that's where we'll put our a. And what we have is 1 minus -4. All right, I think you can still see that on the video. So 1 minus -4 is 1 plus 4, which is 5. So that's going to end up being a 5. Our b, the larger number in b is on top. So we have 5 minus 3, no negatives involved there. It's a little easier, it's just b squared. And now we'll put in our numbers. So we have 1 squared, and we have -2 to the power of 5. And once again, ask yourself, is your final number going to be negative or positive? Okay, if that was a 6, final number would be positive because the negatives would cancel each other out. But because it's an odd number, 5, and because this is irrelevant to the final answer, our final answer will be negative. Because it's going to be negative, I'm going to put that negative in the numerator, and we get 32 because 2 to the 5 is 32. Okay? If you wrote this as a final answer, 1 over -32, I doubt any teacher would mark it wrong. It's just we don't really like to write those negatives in the denominator. Okay? And finally, we have this one here. So what do we want to do here? You know what? Let's be smart and let's just eliminate the b, because we already know that no matter where it ends up, no matter what power it ends up having on it, it will be irrelevant. So we're going to eliminate the b's entirely, and what we're going to do is just work with those a's. So we're going to have the larger exponent on the a's is on top. So that's where my a base will end up. Now we're doing this. -7 minus -9 is -7 plus 9, which is the same as 9 minus 7, which is 2. So we end up with a 2 there. Okay, as I said before, we're going to disregard the b's because we know that they're irrelevant. This a squared, there's no denominator now, so we're just going to raise it to the power of -5 because we haven't dealt with that yet. Then what we're going to do is we're going to go 1 over a squared to the positive 5. We could also have gone a to the -10 and then flipped it. It doesn't really matter, okay? You're going to develop your own preferences for dealing with these, and we get 1 over a to the power of 10, because 2 times 5 is 10. Now we're going to put our -2 in for a. And once again, we've got a negative base. We want to ask ourselves, is our answer going to be negative or positive? In this case, it'll be positive because the exponent is even. So all those negatives that we're going to be multiplying, they're going to cancel each other out ultimately, and we're going to end up with a positive final result. And if you've watched my other videos, you know that this is 1024. 10 goes with the 10 here, 1024. Okay, so that's it for this video. If you liked it, please give me a thumbs up, and please subscribe to the channel and share widely, and we'll see you next time. Thank you.